So one of the popular problems in organic chemistry is ranking acidity, and it comes in many different forms and sizes, but one of the popular ones is electronegativity and size as the comparison. Now, if we look at the periodic table, we have, as you move to the right, electronegativity increases, and as you move down, the size increases. Now, the way you look at it when it comes to ranking acidity, as if you move to the right, you become more acidic, move to the right, become more acidic. If you're in the same column and you move down, you also become more acidic. And then if you're in that same row and move to the right again, you also become more acidic. So that's kind of the pattern that shows up in ranking acidity. So if we look at these molecules over here, we have an R group that's consistent among all of them. That's what we need, right? And then we have these functional groups, and that's all we care about. And so if each of these become acidic, what ends up happening is that they lose that hydrogen, but they maintain the electron pair that's in between with it. And so we get these molecules. We have an R group with CH2, and an R group with an S sulfur group, an R group with an amine group right here, NH, nitrogen, and just chlorine, and then we have an R group with an oxygen or an alcohol group, N. These will all take on a negative charge. And so we're going to compare the stability of that negative charge on those atoms. If we look over here, this is called the conjugate base right here. This is when you have an acid and it gets rid of this hydrogen and has a negative charge. That's the conjugate base form, right? And we're just ranking the stability of that conjugate base. Now carbon over here is the least electronegative, and it's more to the top left of the periodic table. So it's going to be the least stable, making it the least acidic. Over here, chlorine is the most to the right and most to the bottom of the table. And so over here, this is going to be our number 1 most acidic. So this is number 1, this is going to be number 5. And then we compare the rest. If we compare nitrogen to oxygen, nitrogen is definitely less than oxygen. But oxygen is also less acidic than sulfur because the negative charge on sulfur is more stable than oxygen. 1, because it's a bigger atom. And so this is going to be our number 2, right? Because it's bigger than oxygen, which makes this number 3. And oxygen is more electronegative than nitrogen, which makes that number 4. And so that is your ranking stability of acidity by electronegativity and size.